If we could achieve time travel, what will you see? Then our universe will be very different. Today, we are about to embark on a journey through time. Now to the distant future. 18 years later, equivalent to 1 billion years. That's a huge number. Let's take a look at the future 1 billion years from now. And something terrible is going to happen. 1 billion years later, the Earth will become unrecognizable. The once vibrant blue planet. Now, it's a dead brown. The changing colors of the sun have taken away the Earth. All life on the ball. The sun is getting hotter and hotter. Temperatures rise by about 1 degree every 100 million years. Now, the surface temperature of the Earth has reached 47. It's 117 degrees Fahrenheit. This rise in temperature upsets the carbon cycle in the first place, causes plant death, and then the animals life extincts. There may still be some life left in the ocean, but as the temperature rises further, water evaporation, once a beautiful planet, it has now become a dry, dense rock. I can only hope that the humans at that time, before the sun destroys us, has left the Earth, established colonies elsewhere in the galaxy. But certainly not on Mars. Because even on Mars, too close to the sun, humans need to live farther, possibly in other galaxies in the Milky Way, or the outer planets of the solar system with their moons, will temporarily become suitable for us to live in. The once populous Earth will become a distant memory. There is another possibility. Part of humanity may continue to exist in the form of pure artificial intelligence. The person who uploads his consciousness to the machine. It can be almost forever, live in a virtual way. But these machines that carry them, it needs to be located somewhere. Some kind of energy supply, so humans in physical form will still exist. Build these colonies to keep our virtual humans running. This is just the beginning of this journey. Let's push forward billions of years. You will see that the sun is much smaller than it is now. It's about the size of the Earth. It's also white, much darker than before. Over the past 9 billion years, the sun burns all the hydrogen in its core. When its shell starts to burn, he became a red giant. Eventually, as all the fuel runs out, he reached the end of his life as a star, becomes a white dwarf. In his red giant stage, the sun emits so much energy that its outer layers swell, swallowed up Mercury, and possibly Venus. The Earth has been evaporated, shoved into its body core. The sun will cool for billions of years, then reach its next stage, a black dwarf. When the sun goes out completely, another major event is also taking place. Due to the attractive force, Andromeda galaxy, per hour, 400 million kilometers toward the galaxy, two massive galaxies merged. Rocky planets and entire stars will continue to be pulled by attractive forces, and this will continue for millions of years. When the two galaxies finally merge, he has a new name, Megami Galaxy. You thought the stars would collide in this merger, but it's unlikely, because the distance between them is so great. Hundreds of billions of kilometers apart. Scientists have calculated that our solar system has a 50% chance of being pushed away. The core of the galaxy, 3 times farther away than where we are today. There's still a 12% chance our solar system will be completely ejected from this new galaxy. If humans were still alive, we are willing to, will definitely choose a star that will not experience a merger. Farewell to the Milky Way. Keep pushing the time machine. After 22 billion years, things started to get a little more complicated. What is about to happen is called the Great Rip. According to one theory, the universe will tear itself apart. This will be caused by dark energy. This is something that physicists don't understand at all. But they do know one thing. It causes the universe to expand faster and faster. If a major tear occurs, galaxies and clusters of galaxies that exist today will start to stretch each other. Star system, planet, everything will accelerate away from each other, all the way down to their atoms. They will tear apart and dissolve, lead to the end of the universe. Scientists have discovered some evidence. We may be headed towards this demise, but that's not 100% certain. Suppose the universe doesn't rip apart in 20 billion years. This doesn't mean that our universe will be safe. All in 100 trillion years, all the stars in the universe will be extinguished. Let's go back 150 million years after the Big Bang. Stars are born. The rule for stars is that the smaller the star, the smaller it is, the longer you live. Look at this star. It's 8% the mass of our sun. It's too small for light fusion. So it's a brown dwarf. And this big one, about 10 times the mass of our sun. It burns hotter, and it consumes its fuel very quickly. So in about 20 million years, it will go out. You'll have seen our sun. About 10 billion years later. But most of what you see is constant. The stars are smaller than our sun. These are red dwarfs. They're about 8 to 50% the mass of our sun. They have to press more, but they also live longer. About 80 to 100 billion years, you're going to start to see these red dwarfs start to die. And that leaves the brown dwarf. They died a gentle death. As they cool down, their temperature will drop to 2,500 degrees Celsius. This is cooler than most stars. And finally, let's watch the end of this massive star. He is 8 times the size of our sun. His core is collapsing into a huge explosion, created a supernova. This led to the birth of a neutron star. This is a very dense and compact star, or its death could lead to a black hole. In 100 trillion years, you have just witnessed the stellar age. You watch the birth and death of stars, the coming and going of planets and the merging of galaxies. And when the star dies, they will release various elements and substances into space. This usually leads to the formation of new stars. But not all the mass of dead stars is released, and 4 new stars. So the universe will slowly run out of raw materials. Does that mean the end of the universe? Keep pushing time. That is, 1 is followed by 1900 years later. The stellar age is over. We are in the early stages of a new era. It's called the degenerative era. It looks much dimmer than before. It's a universe littered with the remnants of dead stars. White dwarf, brown dwarf, neutron star, black hole. All the stars that have ever been born die. What would happen if there were still humans at this time? One possibility is that we give up matter. The body exists entirely in the form of energy. It shouldn't be the ghost you imagine. But there may be small miracles in degenerative times. For example, if 2 brown dwarfs collide, he might give birth to a new star, can survive for trillions of years. Or if 2 white dwarfs collide, you might see a supernova explosion. But in general, the universe is getting colder and darker. Matter and its smallest building blocks continue to decay. So here, we are in 1018 years. But what happens after that? What will happen at the end of the universe? We fast forward the time to 10. 34 years later, also 1 followed by 34 zeros. The end of the era of degradation is approaching. White dwarf, brown dwarf, even neutron stars will start to die. They won't die because of a process. Become proton decay. The smallest subatomic particles made of them began to disintegrate and die. These white dwarfs will no longer emit a lot of light. On the contrary, they will have the brightness of just a few light bulbs. This decay takes a very long time to complete. If there is equipment, you can watch those little protons die. If the fundamental building blocks and molecules eventually decay, then the fate of the universe seems predetermined. As the proton disintegrates, we have reached the final battle, the future in 40 years. That's 1 followed by 40 zeros. Things are getting bigger and bigger. There are no planets, there are no stars, no dwarf stars, except for a very faint flash. You can hardly see anything. These are black holes. Some scientists refer to this era as the beginning of the black hole era. Black holes will be the most massive structures in the universe. They devour anything that comes close to them, devouring the remains of dead stars. It gets denser and bigger. The only way to escape is just a tiny radiation leak. This is called Hawking radiation. That's how it works. Twin particles keep appearing in space, immediately drown each other. Sometimes one falls into a black hole, and the other one escapes. Over trillions of years, this particle leakage will reduce the mass of the black hole, cause its death. And that's a long time. the last moment. Let's see what happens next. Recognize the future in 100 years. That's one followed by 100 years. Welcome to the Dark Ages. The last black hole in the universe also lost its quality and die at this moment. There are only a few subatomic particles left in the universe, in dark energy. The universe is expanding so much, so that there are very few subatomic particles left, very far from each other. In the entire region of our current universe, to see a single submolecular particle, what a sad and lonely place. Remember the price energy, it will continue to expand the universe further. As the universe continues to expand, it cools down. Scientists refer to this stage as the Great Freeze. All the energy in the universe will be evenly distributed. The temperature will be slightly above absolute zero. It was very, very cold. This theory of the universe has a rather dark ending. But there's another theory called the Great Collapse. Rather than infinite expansion, the universe had reached a point. It turns in reverse and starts to contract. It's like rewinding the video from your old age back to infancy. And then in the embryo. And then the single cell. If that develops, then maybe the entire cycle of the Big Bang will begin again. Or maybe it all happened. We are in one of many cycles of expansion and contraction. Unfortunately, scientists think that's unlikely. It seems more likely that the universe is governed by dark energy, the end of the Great Freeze, even setting aside the Big Freeze. Once we enter the age of degradation, life in the entire universe looks rather bleak. And we need bright, glowing stars to create habitable zones. Life on a planet. So how do we make this a reality? Remember that humanity is only 200 years away from the Industrial Revolution. If I only said that in a few centuries. As humanity had progressed from the first type of civilization to the first 7 types of civilizations, in popular novels, Trisolarans can create independent space. If it can be achieved, that's another story. Please leave a message to express your views.